Hello everyone, welcome to my YouTube channel. Today I'm going to discuss paper 41 0620 May June 2023. Let's start from question number 1. This question is regarding some symbol equations and word equations. So from A to J, the student will have to answer in the terms of A to J, and each equation may be used once, more than once, or not at all. Let me tell you about the type of reactions from A to J, and then you will be able to answer about the type of reaction. Now, this reaction is about the precipitation. This is the precipitation reaction because most of the hydroxide, they are soluble except group 1, ammonium, strontium, and barium. So these hydroxides are soluble. They are in the form of aqueous, and the rest of the hydroxides are insoluble. So that's why we're getting the precipitate by reacting iron 3 and hydroxide. This equation is ionic equation of neutralization. So just look at the type of reaction and then you can answer the required question. Ethane reacts with chlorine to form chloroethane and hydrogen chloride. Ethane is alkane. This reaction is substitution reaction, which is done in the presence of UV light. This reaction indicates that the one compound is broken down into two molecules or the two organic compounds. So this is cracking. Ethene reacts with the steam to form ethanol. There are two methods for the preparation of ethanol in 0620 syllabus. And this is hydration. And the other one is fermentation. So this is hydration. Chlorine plus aqueous potassium iodide, which forms iodine plus aqueous potassium chloride. This is a displacement reaction, or the reaction of halogen, in which the more reactive halogen displaces the less reactive. Glucose is decomposed to make ethanol and carbon dioxide. So this is fermentation. This is the second method which is used to make alcohol at industrial level. Ethanoic acid and ethanol react to form ethyl ethanoate and water. So this is esterification, in which we are getting the ester. So calcium carbonate splits to form calcium oxide and carbon dioxide. This reaction is thermal decomposition. And the reaction in which the carbon dioxide react with the water to form glucose and oxygen, this is photosynthesis. So if we look at the type of the reaction which is happening from A to J, then we will easily answer the required questions. Now, a neutralization reaction, B is a neutralization reaction. Then a precipitation reaction, A is a precipitation reaction. Formation of ester, as you can see in H, there is a formation of ester. Then photosynthesis, photosynthesis is J. Then fermentation, fermentation is G, and cracking is D. So you can answer all these questions from the list A to J if you know the type of reaction which is happening there. Let's come to the question number 2. The symbols of the elements in period 2 of the periodic table are shown. These are the elements of period 2. Use the symbols for the elements in the period 2 to answer the questions that follow. Each symbol may be used once, more than once, or not at all. Makes up approximately 78% of the clean dry air. Clean dry air is the mixture of nitrogen, oxygen, and noble gases. Carbon dioxide is also the part of the air. The major component of the air is nitrogen, which is 78 to 79%. So the answer is nitrogen. Contains atoms with only 3 electrons in the outer shell. 3 electrons in the outer shell mean the element must be in the group 3 of the periodic table. So boron is in group 3 of the periodic table, so that's why B is the answer. Contains atoms with only 9 proton. Proton number 9. So 9 is the proton number of fluorine, so that's why the answer is F. Exists as a graphite. Graphite is the carbon. So carbon exists in the form of graphite, diamond, and these are the different allotropes of carbon. So that's why the answer is C. Is an alkali metal. Alkali metals are the metals which are present in group 1 of the periodic table. And if you look at the group 1 of the periodic table, you can see that the lithium, sodium, potassium, rubidium, cesium, francium, they are in group 1C, but in period 3, there is only one element, and that is the lithium. Has only oxidation number of 0. So noble gases are the elements which have the oxidation number 0, because the rest of the elements, they can react with the different substances to make compounds, and they may have some oxidation number, but some of the elements, they may have their 0 oxidation state in diatomic form. But this is not the compulsory for all the elements. When they react with the different elements to form compounds, they may have their different oxidation state. But neon, noble gas, doesn't react with any element, so that's why it must have a 0 oxidation state. So neon is the answer. Now, state the meaning of the term isotope. Isotopes are the atoms of the element. They are the different atoms of an element with the same proton number with same proton number but different nucleon number. Or we can also say that the atoms of the element which have the same number of electrons and protons but different number of neutrons. Then, and this is the question regarding relative atomic mass. So the relative atomic mass can be calculated by taking the sum of masses and relative abundance. So if we multiply the mass with the percentage abundance, we will get the relative atomic mass divided by the total abundance. So the total abundance is 100. Now the first isotope, the mass is 10, relative abundance is 20, then 11 times 80, and the total abundance is 100. So if you solve this, this is the 1080 divided by 100, and you will get 10.8. So 10.8 is the relative atomic mass of these two isotopes. These two isotopes are the isotopes of boron. This is the relative atomic mass of boron. This question is regarding ionic and covalent compounds. In this question, the sodium reacts with the oxygen to form sodium oxide. See, so the atomic structure of sodium and oxygen are there. The question is that complete the dot and cross diagram of the one sodium ion and one oxide ion. Sodium, as we can see that it has 11 electrons. When sodium is in group 1, when it loses 1 electron, it becomes 1 positive. So we can draw the 10 rest of the electrons because this electron is lost by the sodium and that is accommodated in oxygen atom. So we have to draw another circle in which we can show 8 more electrons. So Na positive contains 10 electrons and the oxidation state of the charge is 1 positive. Now the oxygen, it has ability to gain 2 electrons. When sodium loses 1 electron, there, there must be two sodium ion to complete the outermost shell of the oxygen atom. So we have to draw another circle in which we can copy the number of electrons which are already shown. So to complete octet, sodium must, although the sodium can lose one electron, but there must be two sodium ion, and they lose electron to oxygen atom to become oxide, and this oxygen can gain two electrons. And oxygen is in group 6 of the periodic table, so that's why it has the ability to gain two electrons. Now, this in the next part, uh, write the formula of the sodium oxide. Sodium is Na1 positive, oxide is O2 negative. So if you exchange the number without signs, you will get the formula Na2O. Here we will actually, we are getting the idea that there must be two sodium to accommodate the electrons in oxygen atom. And now this is the carbon dioxide, and the structure of the carbon dioxide. Carbon is in group 4 of the periodic table, so it has 4 valence electron. Oxygen is in group 6 of the periodic table. It has 6 valence electrons, so carbon can make 4 covalent bonds and oxygen can make 2 covalent bonds. So if oxygen can make 2 covalent bonds, so here we can say that there must be a double bond. And like this, so there must be a double bond for the second oxygen as well. So oxygen has 6 electrons in the outermost shell. So 2 are busy here. So you have to show the rest of the 4 electrons. And don't forget to show the rest of the 4 electrons in this oxygen. So carbon dioxide is making double covalent bond on either side with oxygen atom. So this is the dot and cross diagram of the carbon dioxide, and this is the covalent structure of carbon dioxide. So the next question is regarding the melting points of the sodium oxide and carbon dioxide. In the question, we already know that the sodium oxide is ionic compound and carbon dioxide is a covalent compound. Explain in terms of bonding why sodium oxide has a high melting point. Uh, Sodium oxide is an ionic compound, so we can say that the strong electrostatic forces of attraction are present between strong electrostatic forces of attractions between Na positive and O2 negative ions to make ionic bonds strong. So a lot of heat energy is required to overcome these forces. So whenever you have to explain the melting and the boiling point of different substances, just look at the structure of that substance. Sodium oxide is ionic compound, and the electrostatic forces of attraction are present between the oppositely charged ion. So if you want to separate those ions, we'll have to require much more heat energy. So that's why sodium oxide has a higher melting point. Carbon dioxide is a covalent compound. So the melting point of this carbon dioxide can be explained in the terms of weak forces. So here we have to write down just the name of the weak forces. So intermolecular forces. So intermolecular forces are responsible for the low melting point of carbon dioxide, and this is a covalent structure. The molecules are bonded through intermolecular forces, so that's why it requires less heat energy to overcome. The next question is regarding the rate of reaction. Here, the oxygen is produced by the decomposition of aqueous hydrogen peroxide, and manganese 4 oxide is the catalyst, which is used in this reaction. So first of all, state the meaning of the term catalyst. The catalyst is the substance which increases the rate of reaction without being used itself. So the substance which increases rate of reaction without being used itself. And chemically that remained unchanged at the end of the reaction. Then a student adds powdered magnesium or oxide to the aqueous hydrogen peroxide. This is the catalyst, this is the reagent in a conical flask. The mass of the conical flask and its contents is measured at regular time interval, and the mass decreases at the time increases. So this is a British adjustment for this reaction. So hydrogen peroxide is H2O2, and it decomposes to form two products, water and oxygen. So if oxygen escapes this instrument or this conical flask, definitely the mass of the flask and the content must decrease. So state why the mass of the conical flask and its contents decreases as the time increases. Actually, oxygen escapes from the flask during reaction. Then the rate of the reaction is higher at the start of the reaction and rate decreases as and eventually becomes zero. Generally, at the start of the reactions, because we have the higher concentration of the reactants, or we have the higher proportion, higher amounts, higher moles, higher masses of the reactants. So that's why at the start, the rate of reaction must be higher. So if we look at the hydrogen peroxide, we're taking the hydrogen peroxide in the aqueous solution. So we can say the concentration of hydrogen peroxide is higher at the start of the reaction. So that's why it is highest at the start. So due to the higher concentration of high concentration of hydrogen peroxide at the start of the reaction. Then explain why the rate of the reaction eventually becomes zero. The reason behind this question is that if during the chemical reaction, if some of the reactant is used up completely, then the reaction stops and the rate becomes zero. Now, in this reaction, we have just only one reactant. So the hydrogen peroxide is the reactant. And if the hydrogen peroxide is used up completely, then definitely there must be no reaction. There must be no decomposition. So the reaction stops and eventually the rate becomes zero. So the reason is that the hydrogen peroxide is used up completely. And when there is no reactant, definitely the rate of reaction, there will be no reaction, so the rate will become zero. Explain in the terms of collision theory why the rate of the reaction is higher at increased temperature. We know that the rate of the reaction increases by increasing temperature. So when the temperature increases, first of all, the kinetic energy of the particles, increases, and the more particles have energy, equals to or more than activation energy, So frequency of effective cooling increases. This is the reason that the rate increases. So when temperature increases, the particles gain more kinetic energy. So kinetic energy will start increasing. Now, the more particles have energy equal to or more than activation energy, the minimum amount of energy which is required to start the chemical reaction, and the frequency of the effective collision, that will also increase. The collisions per second, when they will increase, the rate of the reaction will also increase. Now, this is the decomposition reaction for hydrogen peroxide. This question is regarding moles. Uh, Calculate the number of moles of hydrogen peroxide. Hydrogen peroxide has the concentration and the volume. And we know that the number of moles, concentration times volume by 1,000. So this is concentration. This is volume by 1,000. So, and this is 0.01. Determine the number of moles of oxygen produced. We can use the stoichiometry of the equation or the ratio of hydrogen peroxide and oxygen. So 2 moles of hydrogen peroxide can give us 1 mole of oxygen. So if you make it half, you will get the moles of oxygen, which is 0.005. Calculate the mass of oxygen produced. So mass is moles times mR. The moles are there, and the mR of oxygen is 32. So we will get the answer 0.16. Okay, next question. State the effect of on the mass of the oxygen produced if the mass of the powdered magnesium peroxide catalyst is increased. This is a catalyst. So a catalyst generally increases the rate of the reaction without being used itself. The oxygen produced, the all the amount of the oxygen produced, that depends upon the amount of the reactant, mean hydrogen peroxide. So there will be no effect by changing the mass of the powdered magnesium or manganese peroxide. So oxygen can also be produced by the decomposition of mercury 2 oxide. So we have to write down the symbol equation. This is the mercury 2 oxide. When it decomposes, we'll get mercury and oxygen. So there are 2 oxygens, so we can put 2 here and then 2 here. Now, this is the balanced chemical equation for the decomposition of mercury 2 oxide. Then move to the next part. This question is about electricity and chemical reactions. The electrolysis of concentrated aqueous potassium bromide is there by using the graphite. Graphite are the inert electrodes. So hydrogen at the cathode and bromine at the anode. So concentrated aqueous potassium bromide is electrolyzed. So we will get the hydrogen at the cathode. Cathode is a negative electrode, and bromine at the anode. Anode is a positive electrode. So the electrolyte becomes aqueous potassium hydroxide, and the state what is meant by the term electrolysis. So electrolysis is the breakdown of of ionic compound in aqueous or molten by passing electricity. This is electrolysis. State why graphite is suitable for use as a electrode. You know that graphite is a good conductor and it is inert. So it is a good conductor of electricity. And the second thing is that it is inert electrode. Platinum can also be used as an inert electrode. All right, an ionic half equation for the formation of hydrogen at cathode. So this is the hydrogen. You will get the hydrogen on the right hand side, and you know that in the electrolysis, It comes from H positive. So if you add one electron, you will get one hydrogen. So theoretically, you have to balance this equation. 2H positive plus 2 electron, H2. Cathode, at cathode, there is a red cat reduction at cathode, and reduction is gain of electron. So 2H positive plus 2 electron, hydrogen. Name the type of particle responsible for the transfer of charge in the conducting wires. So in the conducting wires, the electrons are responsible for the transfer of charge. And name the type of particle transfer of aqueous potassium iodide. Ions are responsible for the transfer of charge in aqueous potassium iodide. Uh, Aqueous dilute potassium bromide. It has four types of ion: H positive, OH negative, K positive, and Br negative. Both the cations, they will start moving towards cathode, and H positive ion is below electrochemical series of ions, so that's why H positive ions are reduced. So OH negative and Br negative. OH negative ions are oxidized at cathode. So if you want to write down the mm, equations, okay, here you have to write down the names of the product. So H positive ions, being a positively charged ion, they will start moving towards cathode, which is the negative electrode, and hydrogen gas will be formed at cathode. So here you will get the hydrogen gas, and OH negative ions are oxidized at anode to make oxygen gas. You will get oxygen gas at anode. And the potassium and the bromide ion, they will remain within the solution. And this thing is already has mentioned. The electrolyte becomes aqueous potassium hydroxide. Now, the bauxite is an ore containing aluminium. So name the aluminium compound in the bauxite ore, that aluminium oxide. Aluminium oxide is the compound which is present in bauxite. State two reasons why the cryolite is used. Generally, cryolite is added into the bauxite to reduce the melting point of aluminium oxide, and it also acts as a solvent, and it also improves the conductivity of the uh, or you can say the whole process. So it is used as a solvent, and it helps to lower lowers the melting point of aluminium oxide, melting point of aluminium oxide, and it acts as a solvent. And we can say that if it acts as a solvent, so it dissolves aluminium oxide. It also improves conductivity by producing more ions, by producing more ions, more ions. Explain why the carbon anode has to be replaced regularly. The working temperature of the cell is approximately 952,000 degrees Celsius, and the oxygen is produced at this carbon anodes, and the oxygen produced at this carbon anode that reacts with to form carbon dioxide. So oxygen produced at carbon anodes reacts to form carbon dioxide. This is the reaction between hydrogen and oxygen. Hydrogen and oxygen react to form water, and the advantage that this fuel cell is more efficient and doesn't produce any pollution.